Good morning, my dear students of class 9. In our previous class, we had seen that modern periodic table is based on atomic number. When we arrange the elements according to their increasing order of atomic number, after certain interval of time, they have equal number of valence electron in any groups. We will see it. And since the number of valence electron of the elements are same, so the elements after certain interval of time they show the similar property. This show of similar property by the elements, it is called periodicity. So what is periodicity? The repetition of the similar properties when the elements are arranged in increasing order of their atomic number. This phenomenon is called periodicity. Later on we will see what is the cause of periodicity to similar electronic configuration. Same valence electron in the valence shell, similar electronic configuration is the cause of periodicity. For example, here is given, consider a group of periodic table. It is first group. Elements are in the first group. If you see, what are the elements? Hydrogen, lithium. Though hydrogen is not written here, but hydrogen, lithium, sodium, potassium, rubidium, cesium and francium, and their atomic numbers are this. What are the properties of these elements? They are good reducing agent. What is reducing agent? The elements which lose electrons, they are called reducing agents. Many times we have come to know right from class 7-8 that all the metals, they lose electrons and form positive ion. Therefore, they are called reducing agents. So since all the elements of group 1A, they all are metals, they lose electron and forms positive ion, so they are good reducing agent. They form unipositive ion. Now what is unipositive ion? Sodium. What is its configuration? 281. Sodium will lose the valence electron. So when sodium loses one electron, it forms one positive ion. Like calcium, configuration is 2882. It will lose two electrons. So when calcium loses two electrons, it will form Ca2 ion, means dipositive ion. But since all the elements of group 1, they have one electron in the valence shell, therefore they all form uni, means one positive ion, and they all have one electron in the valence shell, and they all the elements have one valency. Then they are reactive. Since they have only one electron in the valence shell, therefore they very readily, very easily lose their valence electron. As a result, they are very reactive, and since they are very reactive, so they are not found in the nature in free state. They are found in the combined state. They show different colors when they flame, means when they flow. For example, when lithium is burned, it shows crimson red color. When sodium is burned, it shows golden yellow color. When potassium is burned, it shows lilac color. So These elements impart means they show different colors to the flame when they are burnt. Now, they form hydride with hydrogen. This sodium reacts with hydrogen. It forms sodium hydride, or likewise lithium hydride. But these hydrides are unstable. It is not stable. Very soon and very easily once again they dissociate, they decompose, they break down. They form basic oxides with oxygen. Now question arises, what is basic oxides? See here, if it is sodium, when reacts with oxygen, it forms sodium oxide. It forms sodium oxide. It forms sodium oxide. This sodium oxide is basic in nature. Why it is basic in nature? Because this sodium oxide, when dissolved in water, it forms sodium hydroxide. It is a alkali. It is alkali. So the oxides of the elements of group 1, they are basic in nature. They form basic oxides. These elements of group 1 react with water to form metallic hydroxides and liberates hydrogen. For example, metals of elements of this group reacts with water. Now they form sodium hydroxide and hydrogen gas is evolved. Like potassium, lithium, they all react with water and they form respective hydroxides: lithium hydroxide, sodium hydroxide, potassium hydroxide, with the evolution of hydrogen gas. Another property is all the elements of this group, they all have one valence electron in their outermost cell, one electron in the outermost cell. Therefore, they show the similar properties. Normally, it is assumed, it is seen, it is noticed that the elements with the same electronic configuration means similar electronic configuration, they show the similar properties. Thus, the cause of periodicity is the similar electronic configuration, means same valence electron. So, this thing you once again you will study in class 10. You will see there what is periodicity. So, what is periodicity? The repetition of the properties of elements after certain interval of time is called periodicity. And what is the cause of periodicity? The similar electronic configuration is the cause of periodicity. So cause of periodicity is the recurrence means repetition of the similar electronic configuration. In any particular group, the number of electrons in the outermost orbit remains the same. That means electronic configuration remains same. Valency in any particular group will be same. So the elements of same group have similar properties. Cell may be different because as we move downwards, suppose this is lithium, it has 2 cells, sodium has 3 cells, potassium 4, rubidium 5, cesium 6, and so on. But three things will be same. Valency will be same, valence electron will be same, but the number of cell increases by 1. It is not so lithium will have 2 cells and just below lithium it is sodium, it will have 4 cells. No, it will increase by 1 only. Now there are certain features, there are certain properties of the modern periodic table. This vertical column, this is your vertical columns. These vertical columns are called groups, and this is horizontal columns, they are called periods. If you see, there are 1, 2, 3, 4, 5, 6, 7 horizontal periods, 7 horizontal columns. They are periods. So modern periodic table has 7 periods. Now columns, you can find it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There are 18 groups in the modern periodic table. If you notice it, there were 8 groups in periodic table of Mendeleev, in which 1 to 7 were subdivided into subgroups. Means there were 7 twos are 14 plus 8th group. In modern periodic table, 8th group mentioned in the Mendeleev is divided into 3 groups. So overall it becomes 14 plus 3, 17 plus 1 more group is your inert gases, for inert gases. So 18. So modern periodic table has 18 vertical columns, 1 to 8 as per given in the Mendeleev. 1 to 7 are divided into subgroups A and B. Now elements of subgroups A, 1A, 2A, 3A, 4A, 5, 6, 7A, which is now given as 1, 2, 13, 14, 15, 16, 17. They are called main group elements or normal elements or representative elements. These elements have their outermost cell incomplete. Only the outermost cell are complete. What were the groups? 1A, 2A, 3A, 4A, 5A, 6A and 7A. Now you see your page. This is 1A, 2A. It is representative elements. Then here also come 3, 4, 5, 6, 7A. They are representative elements. They have outermost cell incomplete. Then elements of group 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. They are transition elements 3, 4 up to 12. 3, 4 up to 12. Here is your 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right from here up to here, they all are called transition elements. Their outermost cell is also incomplete. We will see their properties one by one in the next class. Then elements of zero group. Zero group means group 18. They are called rare gases because they are very rarely found. They are found in small trace. So they are called rare gases, inert gases or noble gases. Since their electronic configuration is according to electronic configuration, except helium, all the rest 5 except helium, there are 6 inert gases. Helium has 2 electrons in the valence shell. Rest of the inert gases like neon, argon, krypton, xenon and radon, they have 8 electrons in the outermost shell. So their outermost shell is complete. So therefore they neither lose nor gain nor share electron. Therefore their valency is 0. Therefore the elements of group 18 are also called as your 0 group elements. Now periods. There are 7 horizontal periods, 7 horizontal rows. See, I had shown you there are 7. So there are 7 horizontal rows. Each row is called period. The number of cell represent an atom and determines its period. For example, number of cell. If there is one cell, it will be the element of period 1. For example, this hydrogen, its configuration is 1. It has only one electron, so its configuration will be 1. So it will be in the first period. Lithium configuration is 2 1. There are 2 cells. It is the element of period 2. Sodium has 2 8 1. There are 3 cells. This will be the elements of period 3 and so on. Therefore, the number of cells determines in which period they belong. Elements with electrons increasing arithmetically in the outermost cell, that means one by one till an octet is attained, are placed in same period. The last element of each period has 8 electrons except helium. If you notice here, it increases by 1. Here the valence electron is 1. Here is 2, 3, 4, 5, 6, 7. Here in the boron, before boron, what is configuration? 2, 3. 3, 4, 5, 6, 7, 8. So the valence electron is increasing. 1, 2, 3, 4, 5, 6, 7, and at last it comes 8. The last element of his period. Okay, now the first period has only 2 elements, so it is the shortest period. If you see in the first period, there are only 2 elements, hydrogen and helium. In second period, there are 1, 2, 3, 4, 5, 6, 7, 8. In the third period, 1, 2, 3, 4, 5, 6, 7, 8. So first period has only 2 elements, so it is the shortest period. Second and third period, they contain the elements. How many? 8. Their atomic number is from 3 to 10 in the second period and 11 to 18 in the third period. Fourth period, it contains 18 elements. You can count it, whose atomic number ranges from 19 to 36. They are long periods. But sixth period as well as seventh period, sixth and seventh, they contain 32 elements. Sixth period, in sixth period and group 3, they are called Lanthanides. They have 1, 2, 3, 4, 5. There are this plus this one. Total overall they have 32 elements. Similarly, period 7, it has 32 elements. So period 6 and 7, they are the longest period. Then in group 3b, group number 3 of 6 period, this to this, being the lanthanum, these elements are called lanthanides. If you will see here in period 6, this one is your lanthanum and it contains another 14 members. Here it will be 15, no problem. So It contains 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this lanthanum, now they contain this much number of elements. So these elements are called lanthanides, whose atomic number varies from 57 to 71. Likewise, the elements of period 7 and group 3 atomic number vary from 89 to 103. It is this one, if you see, it is what? Actinides. So this actinide also includes 1, 2, 3, 4, 5, 6, 7, 8 up to 15. These all elements are called as your actinides. So the group 3b, so group 3 of the 7th period, there is a set of elements with atomic number 89 to 103 with actinium. These elements are called as actinides. Lanthanides and actinides have similar properties because they belong to the same group 3b, but they are down the group. They are given place at the bottom of the periodic table. They are not included. They are, this much is the main part of the periodic table, but these are given separate place. If they are included in here and here, it will destroy the periodic table. That's why it is given separate place. So my dear student, it is for today. In our next class we will see the different types of elements. Wish you all the best. See you. Bye.